সবুজ পাতায় আমরা প্রদীপ জ্বালি সাক্ষরতার শক্তির ঝর্ণা ঝরায়। হলদিয়া শোধনাগার, হলদিয়া শোধনাগার। ভেসে যাওয়ার পথ পেরোবার এমন বন্ধুকে পায়। আধারের পাথারে ঘরে ঘরে আলো জ্বেলে দেয়। হলদিয়া শোধনাগার, হলদিয়া শোধনাগার, হলদিয়া শোধনাগার।
Namaskar. As you all are well aware that the world is going through a tough time with lot of hardship and difficulties due to pandemic and their effects. It has really become a difficult to accomplish the task without safe alternate to avoid risk of life, which is precious. Training department has to play a vital role in imparting training to its own employee as well as to the trainees, whether they are apprentice, they are summer or vocational trainees, to upgrade their knowledge and skill. As a special case, without hampering the enrollment of trainees and even visiting the site or units for the purpose, we are making it possible through audio, video means, webinar, etc. with our unit, section, department, experts for the maximum benefit of yours. I really feel proud that my team has took the initiative, and with their efficient and effective coordination among themselves as well as with the interdepartmental officers, technical experts of various units, section, department has made it possible. Hope you will get maximum inputs in acquisition of knowledge through our experts. You may surprise that Haldia Refinery may be the first among the other units who have taken such initiatives. All the best. Be at home, be safe, and adhere the COVID guidelines. Thank you. Thank you very much.
Good morning. Myself, Jaideep Chatraj. I am Senior Manager, Mechanical Maintenance. I will be giving a training on the topic pumps and compressor. So, what are the learning objectives? By this end of this course, we will be able to recognize the motion of the fluid, pump, what is pump, and what it is used for our daily life, understanding the use of pump in our process plant, familiarization and classification of the pump. This is basically the content of the course. Now first we start with a simple analogy, that pump and our human body. In our human body, the heart, which functions as similar as a pump, it pushes the blood in all the parts of the body. The same thing is happening in our process industry also. We need to carry various liquids, various process fluid from one place to another, and for that pump is required. So This is our human body pump, which gives the fluid, incompressible fluid, to the various sections of our body, similar like a process plant. So this is the heart. Now, if the blood to get a elevation for the different part of the body to reach to the head, to the elevation, it requires a head. So for that we require that head, or we require the pressure, which our human body pump gives. So this is what we are means. It maintains the pressure according to the need from low to high. A similar activity in the process fluid or any fluid, it generally comes down with the gravity. It doesn't require any pump or doesn't require anything. The liquid will flow from upper portion or from a elevation to a downwards in a normal process, that is due to the gravity. But if we want to do a reverse, means want to lift the liquid from a lower level to a higher level, we need an energy to move it. This is a simple application of the pump in our houses, where or in our underground slum we store the water, and we need to push the water to the overhead tank for the supply of the house, and for this purpose we require the pump, which gives the energy and pushes the liquid to the top of the roof. This is a process industry where a gasoline, means our petrol, it is being moved from place A to B. Now one process is that it is moved through a truck, and another process is through a pump. So basically pump is pressurizing the fluid, increasing the pressure of the fluid. This is a simple example in the petrol pumps. You see there is also a very small pump which is running and pressurizing the liquid or the gasoline, which will be forced and loaded to your tank. So this is what is a pump. A basic definition: a device that moves the fluid through a mechanical action. Basically pumps do a conversion of energy, means a kinetic energy which is converted into pressure energy and force the fluid for a higher elevation, longer distance, or a higher pressure. This is a picture of an industrial pump. The blue portion is the motor or the driver. In between there is a coupling which couples the driver with the pump, and the pump pressurizes the fluid from suction to discharge to the final location. Now this is the application in the process plant. General application of pumps in industries such as refinery and petrochemical are transferring the liquid. This is a small glimpse of our refinery. The long columns are there and pipings are also seen. Now pumps are required to push the liquid from the bottom of the tank to this column, or from the column extract to another location. Basically from the lower pressure to the higher pressure region, or the lower elevation to the higher elevation. Pumps deliver fluid faster and improve the process. That's why it is required, because as our throughput or our production rate is depend on this pumping rate. Some other applications are also there, such as for the fire water, sprinklers, driller system. Now we are coming to the types of the pumps. The pumps are basically of two types. One is kinetic or rotary type, another is positive displacement, where the incompressible fluid is positively moved from one place to another and it increases the pressure. The kinetic pumps are basically, kinetic or rotary pumps are of two types: centrifugal and special service. Special service will go into a detail. And positive displacement, there are two types. One is rotary type, means where rotational motion is creating that positive displacement, and another is reciprocating motion creating that positive displacement. Rotary pumps are divided into 4 different categories such as lobe pump, screw pump, gear pump and vane pump. We'll see some examples of such pump. First of all, the most commonly used pump is the centrifugal pump, where it is basically a constant pressure pump. In the middle of the section you can see a impeller. This impeller is basically rotating the fluid and increasing the pressure and giving a discharge pressure. It is working same as a reciprocating type also. Reciprocating type, here the piston, it is moving and pressurizing the fluid from lower pressure to a higher pressure by a positive displacement of moving. The difference between centrifugal and positive displacement is that in a centrifugal pump we have a slippage, means all 100% liquid is not forced to the discharge, but in a reciprocating pump 100% fluid is pushed through the discharge. So that is why it is called a positive displacement. But in centrifugal, some part of the fluid is going to the discharge and some part which could not attend, it go back or it slips. These are some types of rotary pumps such as lobe pump. Here you can see 2 lobes, they are rotating and the entrapped fluid, that is the red or bluish line, bluish fluid, it is getting pressurized and moving from one direction to another. Basically what it does in a lobe type pump, one, they entrap a fluid from the suction and force it to the discharge. And the control volume is the gap of this lobe, is that fixed volume which is moving from suction to discharge. Similarly, screw pump, here 2 twin screws are rotating and the entrapped fluid between the 2 screws are progressively going from one to another location, means from suction low pressure region to high pressure region. So the energy which is moving the screw, this energy is pushing the lower pressure fluid to the higher pressure portion. Similarly, the gear pump, here the main driven unit is gear. The gear also is having a entrapped volume, and that entrapped volume is getting from lower pressure to higher pressure. For going to a higher pressure region, it requires energy. Without that energy, we cannot move this fluid from lower pressure to higher pressure, and that's why we require this pump and a driver, a motor which is giving the energy, which is rotating this gear or screw or lobe and pushing the fluid from a lower pressure region to the higher pressure region. This is the vane pump, the last one. The red portion is the vane which is being rotated. It also, the principle is same, it is also entrapping the fluid and it is pressurizing the fluid from a lower pressure region to the higher pressure region with the help of the driver or the energy. Now, how the centrifugal pumps work? This is a very simple example. If you rotate a impeller or this type of vane in a cylinder, you will see the head rise. Means in one tank you see, without the churning or agitating, the fluid level is same, it is on a same place. But when we are rotating, some fluid is thrown away by the centrifugal force. The formula is very simple, the centrifugal force formula, U square by 2G. With this force, some liquid is going out. In a centrifugal pump, similar thing happens. When an impeller is being churned in a fluid, it pressurizes or increase the velocity of the fluid at the end and it gets a head or a pressure which is being collected in the discharge pipe and thrown to the process. This is another example of the basic operation of the centrifugal pump. The fluid is going to the suction eye of the impeller and it is being rotated by the impeller and it gets the motion in the cut water is you have seen that there are volute casing have a less gap region. This one is called area is called cut water section, from where it collects the liquid and it's going through the more gap region and going to the discharge pipe. So in the first region there is a high velocity but the low pressure fluid, and in this portion in the wider region there is a low velocity high pressure fluid. Basically the velocity is converted into the pressure. So the centrifugal pumps works on this principle of this centrifugal force. And the gap between the impeller and the volute is constantly increasing, which is adding the extra liquid to this gap, and the liquid is getting a velocity through the rotational movement of the impeller. That rotational motion gives a velocity to the fluid, and this velocity, when get resistance, it transform into the pressure. So this is a general cut section of a pump. In the middle you can see the impeller, and it is holded by the bearings. Then thereafter the prime mover, and it is coupled in between. The horizontal portion is the suction side and the vertical portion is the discharge section. Some nomenclature we use such as this base frame. This is the casing of the pump. This is the suction nozzle from where the fluid is entered to the pump, and this is the discharge nozzle from where the fluid is going out. This is the packing portion which prevents the liquid to coming out from the pump. This is the gland cooling tubes used for cooling, because there is a huge friction in the gland, as the rotary shaft is getting a constant frictional force in the packing area, so its temperature is getting rise. So there is a gland cooling arrangement to cool down that temperature rise. Second is the bearing housing, which holds the impeller in a position with a to have a static versus rotary friction. The bearing housing is a static part, and the shaft which is holding the impeller is the rotary part. So there is a transition between the rotary and static, and that transition is happening through a bearing. What we are basically doing, we are converting a sliding friction to a rolling friction, because as you know the rolling friction is always less. So for greater efficiency we are using bearing to reduce the friction, and friction is the loss in energy, because here the prime mover motor that is giving the energy, the electrical energy going through the this motor is converted into a mechanical shaft energy. That shaft energy is churning the liquid and giving a velocity, which in turn convert into the pressure, and the losses are the friction. Whatever friction we are having in this system is the loss, or that is lowering the efficiency. So our prime action is to reduce the friction in all the way. So there we use the lubricants and cooling so that the friction gets minimized. And the bottom portion is the foundation, because to get this pump a good hold, as this pump is a rotary machine, it always do a vibration. So to get rid means with this vibration the pumps will get damaged in long run. So that's why a heavy foundation is made to hold the pump and the motor. And this is a coupling guard. This is basically a protective device, so that the rotating part, if the person nearby, they can come contact with this rotating part, which is rotating at around 3000 rpm speed, and it can get harmed. So this is a safety coupling guard is being installed. And now the main component of this pump, shaft and impeller. Shaft is holding, means this is the main part, rotating part, which is transmitting the force from the motion from the motor to impeller. and impeller is the thing which is giving the rise of velocity and the pressure. Now for the, this is a single stage pump. Now for the multi-stage pump, the same thing is happening, only instead of one impeller, there are number of impellers, and the discharge from one impeller is going to the another impeller suction, and then the discharge of the second impeller is going to the third impeller, then from the third impeller to fourth impeller. This arrangement is little bit different because here we need an axial thrust balance. Pump has a two side, one is higher pressure side and another is lower pressure region. So there is always a thrust or a force which is pushing these impellers to the higher pressure to the lower pressure, and this thrust need to be balanced. That's why the impellers are arranged in such a way that one thrust and another thrust, they cancel each one out, and ultimately there should not be any imbalanced thrust. So a multi-stage centrifugal pump has two or more impellers. Why we are giving a multi-stage pump? Because if we can do it with one stage impeller, but one stage impeller will become a larger. If our pressurized requirement of pressurized is more, then we require a much larger impeller, and such a larger impeller may not be feasible to manufacture. So in that case, we require a small number of impellers. Means we can split that a large impeller into number of impellers, so that the effect of the head rise will remain the same, but our volume or the size of the pump remains small. So this is one of the construction of the multi-stage pump. This pump can be made with a one impeller, but that impeller size will be very big, which will be combining the diameter of all these four impellers. So it will be a large pump. So to reduce the size of the pump, this type of arrangement or multi-staging arrangement is being done to get the requirement of the pressure. Now the most important thing, why we require the pump? We require the pump to overcome the head. In the first few slides I have seen, I have shown that heart, what it is doing, it is pushing the blood from all the parts of the body, overcoming the resistance. And in the another photo I have shown you that from a water is falling from a higher portion to a lower part through gravity, but if we want to do the reverse, we require energy to overcome that head. So understanding this head is very important, because that is all depending the selection or designing or sizing of the pump. So this is the picture. I am showing you the two cases. One portion where the liquid is in bottom sump and it is giving to a top tank, and another in the case B, both suction and the bottom suction tank and the discharge tank both are at the elevation. Means the suction tank is also above ground and the discharge tank is also above ground. So here, what is the total head? Means what the head needs to be overcome. For the first case, you see the pump center line is the basic reference from where the head is being measured. So you can see this hatchet line is the center line of the pump, and from the center line of the pump we can see that the static head, the head means which is required to overcome, or head or the height which need to be overcome by the fluid to reach from the center line to the top. And another is the static suction lift, which is the bottom, means from the center line and the top of the bottom tank, that is the suction lift. Now the total head of the pump is this, the addition of this suction head plus discharge head. This concept is very important concept, because this gives a lot of difference. This requirement means if the pump is sucking a liquid from a lower level and giving to a higher level, then it requires a more head, rather than a pump which is taking a suction from a above ground tank means above the central line and giving a liquid to the above ground. In the second case B, the total static head is the difference of the discharge static head and the suction static head. This is explained in the equation. So the suction head, static head is measured by the subtracting the static suction lift and static discharge head. Now, it is not always the same or the arithmetic one. If the pump is taking a suction from a lower level, then it may have a vacuum. So it's a negative pressure. So the formula is that the total static head and the suction head is basically it is a vacuum. So it is in minus. So ultimately the suction head plus suction means the discharge head plus suction head. This will become the formula. And for the case 2 pump, it is the suction head minus discharge head. Now we have to understand another important thing, that is the net positive suction head, which is required and which is one of the utmost criteria for selecting centrifugal pump. Definition: the suction specific head. This is the real or the actual positive head above zero pressure of the absolute energy which the pump requires to lift. Now we know above us the atmosphere is there and atmosphere is constantly pressurizing us. So we are always having a constant atmospheric pressure on all over the things in this earth. So this pressure of the atmosphere is equivalent to a 10 meter of water column. So this is the absolute pressure. Wherever our gauge pressure is 0, there also we will have this 10 meter of the absolute pressure. Now the pump or centrifugal pump cannot lift from vacuum. It must have some positive suction head. Without this positive suction head, it cannot lift. Now for the case A, the NPSH is 10 meter. In this figure you can see a tank which is at the center line of the pump. So atmospheric pressure is on the liquid level, so it is having an absolute pressure of 10 meter. So this is a zero suction lift, no suction lift is required. It is at the water level is at the center line of the pump, so it is having a 10 meter of absolute NPSH and it can give the flow. Now if in the next picture, if the sum is 4 meter deeper than the center line, then what will happen? The positive atmospheric pressure on the tank is 10 meter and it is having a bottom height of 4 meter. So the actual NPSH is 6 meter. So pump have a available or the net positive suction head available is 6 meter. Now another case where the tank is above ground, above the center line, it is 8 meter above the center line. It is having a 10 meter of constant atmospheric head above the tank and it is also above the 8 meter. So NPSH is 10 plus 8 and that is 18 meter. Now we will talk about the operations of the pump. In the centrifugal pump, if we run two pumps in parallel, then the simple thing is that both the volume will add but the pressure will not add. You can see two pumps having a 100 meter cube flow and 4 kg pressure. When they are connected in parallel, then the total flow will become 200 and the head pressure will remain same as 4 kg. But in the series operation, it's different. If two pumps are arranged in series, then the flow will remain same 100 meter cube, but the pressure will go on adding. First, the pressure, maximum discharge pressure was 4 kg, and for the second, it is 12 kg. But in the second pump, the suction pressure is 4 kg. So the actual pressure left by the second pump is only 8 kg. So the first pump is having a delta pressure of 4 kg, and second pump is having a delta pressure of 8 kg, and altogether 12 kg pressure is being generated by these two pumps in series. Now we will tell about something about the codes and standard of the pump. As we are known, this pump is a universal thing. It is available in the market, it is available with the vendors, and we require some pump. So there should be some basic standard which the purchaser or the person who requires the pump they require, and the manufacturer who make the pump they prepare. So there should be a bridge between the manufacturer and the purchaser. So these codes are for this. Now API, in the petroleum industries, we generally use API standard. API is American Petroleum Institute. It gives a standard for all the purchaser and manufacturer of the petroleum industry, and there are number of codes. Codes are generally denominated by the number. So the standard number 610 API 610 is the standard which is covering the centrifugal pump. How the centrifugal pump will be designed, what are the features of the centrifugal pump, these all are written in this standard, and this is the standard which we follow and the manufacturer also follow. So whenever we want to purchase a pump, we mention this standard number only. We want a API 610 pump. Then what are the things required for the API 6, how the pump will be designed, how the pump will be selected, all guidelines are there, and both the purchaser and the manufacturer both are guided by this standard. Both have to comply. Means the purchaser cannot ask for something which is not possible, and the manufacturer cannot design something which is a very cheap thing or which is not good for the service. Then API 614 standard, this is the lubrication or the shaft sealing standard. API 670 standard, API 671 special purpose coupling, and 682 is the mechanical seal standard. So these in the pump drawing which I have shown earlier, where you have seen one pump, another is the lubrication, sealing and the bearing system, then the vibration and the coupling which is coupling the motor with the pump, these all, and the gland or the mechanical seal. These all are being covered with this API standard. So whenever we want a pump for industrial purpose, we use this standard in the market to get the actual or the required pump. Now next we will go for a compressor. Now in the first stage, what we are talking about the pumps, because in the process industries we have two type of fluid. One is compressible, one is incompressible. One compressible fluid means gas, and incompressible is the liquid. So for the incompressible fluid, we use the pump for transport from one place to another, as I have shown in the last presentation, in the application from lower head to higher head. The similar thing is required in an industry for gases or the compressible fluid also. But there is a lot of difference between the compressible fluid and the incompressible fluid, means the liquid and the gases. The properties are different, the centrifugal forces are different, so total the equipment is different. We require a different equipment. The equipment which is required to transport a liquid or a compressible fluid from incompressible fluid from a lower pressure to higher pressure region is not the same for a incompressible fluid. Now we are talking for a compressible fluid, that is for the gas. This is our learning objective: understanding the compressors, identifying the types and their function. As I have given an analogy of heart for pumps, means as we have heart which is pushing the incompressible fluid, that is the blood, to different part of the body. Similarly, we also have another compressor in our body, and that is our lungs. There is a diaphragm in our body which sucks the air in and gives the air out. It is working as same as a reciprocating compressor. When the diaphragm gets in, the volume of the our lungs increases and it sucks the air inside, and then again when the diaphragm gets squeezed, the gas is getting pressurized and it goes out from our body. So these are the contents of this course. Now, first thing, the compression. What we need to know is the compression. Compression is as a compressible fluid gas, it can be compressed. As liquid cannot be compressed, but gas can be compressed. If there is a volume V and a pressure P and temperature T, these three are constant, then if you increase the pressure, the volume will decrease and the temperature will also increase. So this, I think you have already covered in your basic physics course, which we show in a little bit in this course to just to correlate with the academic courses with the industrial application. So this is the basic thing which you read in your basic physics book, but this physics principle is all applied in our compressor. With this basic physics principle only, we are doing a complex designing of compressor. So this is the simple thing. If we half the volume, if we keep the volume half, then the pressure will increase and the temperature will increase. So in a molecular moment, if we in the low pressure, the molecules are in distributed state, and with the high pressure, molecules are in concentrated. So what compressor is doing? It is giving a energy. It is compressing the molecules to a lower dimension or a lower volume. So this is the compressor, which is looking similar to the pump, but it requires a more energy because incompressible fluid requires less energy to get pressurized. Because in an incompressible fluid, the liquid molecules are almost closely packed, so no energy is consumed in compressing the internal molecule. So whatever energy we are giving, those energy is directly converting into the liquid head energy. But for the compressor, it is not so. Then the compressor first, whenever we give the energy, it will first give the it will increase the density of the molecule, it will increase the compactness of the molecule, and then it will get the pressure rise. So the consumption of energy in compressor is much more or much higher than the pump. Now, in our daily simple life, where we see the use of compressor, simple, when we try to inflate our tire, we use a compressor or a simple hand pump to increase the pressure of the air and to put it into the tire. Similar, another experience in our natural daily life is refrigerator, where we are having one compressor which is compressing the refrigerant gas from a gaseous stage to liquid stage, and then heat is absorbed, liquid is again converting to gas, and these cycles go on. Now, in the industrial application, when we are handling hydrocarbons, when we are heating hydrocarbon in our industry, some of the lighter hydrocarbons, they are converted into the gas. As we know that the methane, ethane, propane, means C1, C2, C3, these all are in gaseous state. In the oil industries, the input well or the crude oil is a mixture of all sort of hydrocarbons. When we heat them up, then it get detached and the smaller hydrocarbons will go out as a gas, such as a LPG gas, which is C3. So we need to transport this gas from one place to another to to store this gas from column to some other tank or a bullet. We require this gas to force from a lower pressure to higher pressure region, or a lower head to a higher head region. For that we require a compressor. So basically the transportation of the gases, and it is also used in the air separation plant. In the steel industry also, there also a lot of gas is being generated in the furnaces, blast furnace. A lot of gas, burning blast furnace gas is being generated. That is also need to be transported, and there also we require a compressor to transport this gas. In the petrochemical, there are also polymer, polyethylene. We also require a compressor for the transportation of the gas. Now let us come to the basic principle or the basic operation principle, which is similar to the pump. It's all about the changing the kinetic energy to pressure energy. Now, as I have told you during the session of pump, that some energy what we are giving as a unit input is lost due to the friction. Similar is the case of compressor. Whatever energy we are giving, some is turned to the gas energy, gas kinetic energy, and some is to the liquid, some is wasted due to friction. So the overall efficiency is always less than 100%. Now some basic thing, that the units of measurement, Newton per meter square and the Pascal. 1 bar is equal to 14 psi, because these are required for understanding further. So these are the basic theory which I am being told. This means the difference between the liquid and gases. Liquids are incompressible and gases are compressible, and that's why the theories are also different. Now for the compressor basis, we require 2 or 3 gas laws. One is Boyle's law, another is Charles' law. Now for the Boyle's law, as long as the temperature of the gas does not change, increasing the pressure will decrease its volume. This is very simple. If we decrease the if we increase the pressure, the volume will get decreased. Basically, the pressure into volume will remain as a constant. If we increase the pressure, volume will decrease. Volume will increase, pressure will decrease. And the Charles law is with the temperature. If we give a temperature, then with a constant volume, if the gas is held with a constant pressure, the volume will increase if the temperature is being increased. So this is the formula, V1 by T1 is equal to V2 by T2. And now combining these two, both gas law, the relationship is something like P1 into V1 by T1 is constant. P1 by P1 into V1 by T1 is equal to P2 into V2 by T2. And this is the basic principle which is being used in compressor design or in the all compressors. So the first thing is the compression ratio. What the compressor will do? It will do increase suction pressure, increase a lower pressure air to a higher pressure. So there is a one discharge pressure and one is suction pressure, and the discharge pressure by suction pressure is the compression ratio. This is the basic guiding principle of designing a compressor. Now, what is the capacity of the compressor? Capacity of the compressor is basically the volume flow. How much volume is being flown, and that can be simply measured in meter cube or in liter. So the typical parameters of a compressor are suction pressure, discharge pressure, suction temperature. As I have shown in the pump, the compressors can be connected. In fact, in industry, we always see the compressors are being connected. The first stage, second stage means compressors are connected with in series to reduce their size. In the same case, as I told you in the pump section, if we design a pump with a single impeller, then its dimension of the pump will increase to manifold. So we need to reduce it. So we divide into number of stages. Similarly, for the compressor, we require to divide into stages so that the total entire system for a desired purpose remain compact. So here also we are seeing a parallel connection and the series connection. Parallel connection always increases the capacity, and the series connection, these two compressor connected in the parallel, they will increase the flow but not the pressure. But whenever they are connected in series, this is one thing, that when the compressors are connected in parallel, they adding the flow but not the pressure. And in series connection, the volume remain the same, or the flow remain the same, but the pressure will increase. Means one compressor will increase pressure head, the second compressor will further increase its head, and in this way they were go on adding the heads, and ultimately the compression ratio or the discharge head and suction head will increase. So this is a series connected compressor. The flow is getting into the first stage, then a medium pressure is generated, and that medium pressure is going to the second stage, and it is giving a higher pressure. But the volume flow rate in the first compressor is same as the volume flow rate at the last compressor. So when compressors are connected in parallel, we can do what we can do. If we are connecting 3 compressors in parallel and then we are running 2 compressors, then if we require to stop one compressor, then we can run another compressor and stop another, so the total volume flow remains the same, and we can make one compressor redundant for maintenance. So that is the basic principle for connecting the compressor in parallel. And whenever full capacity is not required, we can stop one compressor. But if we use the compressor in series, then the flow will be stopped if one compressor is being stopped. Now this is a compressor cross section, screw type compressor. The screw type compressor is a positive type of displacement compressor, where it is same as the screw pump. There is an entrapped volume of in the pump case it was a liquid, and in compressor case it is the gas. So entrapped gas is between the two screw space, and that entrapped volume is progressively going forward from a lower pressure to a higher pressure region, means from a suction to discharge. So this is the male rotor portion, and this is the female, means another rotor. The gas is entrapped between these two rotors, and this is the casing. This is the radial bearing which is holding the rotary part with the static part. and we use the bearing in such a way that the friction should be less. And we required one shaft sealing also, so that the gases should not come out from the compressor unit to outside. So this is the gas inlet and gas outlet. Now types of compressor are as similar as pump. Two types, one is positive displacement and another is dynamic or centrifugal type. So positive displacement pumps are two types, one is reciprocating and another is rotary, and dynamic is centrifugal and axial. Now the next is the selection of the compressor. How we select the compressor? Basically what we require, why we need a compressor? We need a compressor to transport some gases of a particular volume as per our requirement from a certain low pressure region to certain high pressure region. So our requirement is a quantity of gas or the flow of gas and the delta pressure, means the low pressure, and means the difference between the high pressure and the low pressure. So these two are the basic requirements. With this requirement, we are going to select the compressor. Now, in the first case, if we require a high pressure, but the low flow, then we should select reciprocating compressor. Because reciprocating compressor is a positive displacement type compressor, its compression ratio is higher, so it can increase the head from lower to higher, but it has a limitation in volume. Means volume, for the volume capacity, the compressor size will increase like anything, means compressor will become bigger. So after if we require a very higher volume, then this reciprocating compressor will become a very robust or very big. That size is not suited. So for the reciprocating compressor, the selection range is high head and low flow. Wherever flow requirement is low and the head requirement is high, we select reciprocating compressor. Now when the head requirement is moderate but the flow requirement is more, we require more flow. So in that case, we are using centrifugal compressor. So centrifugal compressor, but for the very low flow, centrifugal compressor is not suitable. There will be a problem of surging. So centrifugal compressor should have some minimum flow. Reciprocating compressor can be designed for a very minimum or low flow, but centrifugal compressor cannot be designed for a low flow. And for a very high flow and low pressure region, axial compressors are being selected. And this is the middle portion is a screw compressor. Screw compressor is something in between reciprocating compressor and centrifugal compressor. Its actions, it is a positive displacement compressor, so its basic principle of operation is same as a reciprocating compressor, but as it is rotating, its efficiency is going like a centrifugal compressor, so it's operating between centrifugal and reciprocating. But screw compressor also have a limitation, it cannot work with a very low flow. It will also having a problem of surging. Now, a PNID symbols of a compressor, how we denote a compressor. This is a symbol in a PNID or in a drawing where we use compressor, and these are the parameters which are used for design the compressor, that is the pressure, temperature, volumetric flow and the mass flow. This is rather the PNID symbols. Now coming to the driver or the prime mover. For both the compressor and pump, we require a driver or a prime mover to give the energy, means the electrical energy or a steam energy or something need to be given to this pump or compressor to energizing the liquid, either compressible or incompressible. So what are these driver or prime mover? These are electric motor, gas turbine, steam turbine, diesel or a gas engine, power recovery turbine. These are the different types of prime mover. Now from the name itself it is knowing that the electrical motor is to work on electric. Gas turbine, it is using the gas is being burned and energy is generated, which that energy in turn the rotor. Steam turbine is the steam energy which is being consumed and gives the kinetic energy to the rotor. In the diesel, the energy source is diesel which is being burned and rotor energy is being generated. Power recovery turbine is another process thing. Power recovery turbines are wherever we are having some excess power, means in this total training I have shown you that the movement of the incompressible or compressible liquid from a lower energy or lower pressure to a higher pressure region. But in the process industry, there are some places where the higher pressure gases are present and we need to discharge them in a lower pressure. So the energy is being wasted. Means that high energy gas or the higher pressure gas, if we need to discharge it, then the pressure will be lost and the energy will be lost. To recover that energy, we use that power recovery turbine, which in turn means that high pressure gas or liquid, whatever, it pass through this turbine and it gets the kinetic energy. This kinetic energy is working as a prime mover and it in turn give the energy to the pumps or compressor. So this is the end of this course, which gives a general overview of pumps and compressors. So one last recap, what we have learned: the industrial processes, why we used the pumps and compressor, that is for flow of compressible or incompressible fluid from a lower pressure, lower head region to a higher head or a higher pressure region. For that we required pump or compressor, pumps for the incompressible fluid, compressor for the compressible fluid. Compressor required higher energy because compression required more energy, pump required less energy. These two types are their basic principles are based on two basic categories. One is positive displacement principle and another is rotary or the centrifugal principle, which has been explained. Then their division or construction is based on that. Then a head rise, and for the pump the net positive suction head, which is very important to select a pump. A pump will not function unless and until it have a net positive suction head. This problem we face in our house also. Whenever our tank level goes down and it doesn't get the required net positive suction head, then the pump cannot give the water. You face this problem in our daily life. Sometimes your pump get cavitated, sometimes your pump could not give the proper flow because of the net positive suction head. And for the compressor also the suction head is required, but that is little bit different from this incompressible fluid suction head. And the next thing is the operation series and parallel. If we put the pump or compressor in parallel, then the flow will add, and if we add the compressor or pump in series, then the pressure will add. And the last is the selection for the low head, for the high head and the low pressure region, a low volume flow, we require positive displacement or reciprocating, and for the high flow and low head we require centrifugal, and in between is the rotary, that is the screw, gear, lobe. These types of pump or compressors are in between region. So high head and low flow is the positive displacement of the reciprocating region of selection, and high flow with low head is the centrifugal region of selection. And lastly, the drivers, that is the electrical motor, power recovery turbines, and gas turbine and diesel engine. These are the drivers which gives the energy to this pumps and compressors. I hope that you will be benefited through this session and be at home, be safe, and follow all the COVID guidelines. Thank you to all.
मेरा करम मेरा ईमान है, मेरी आन मेरी शान जान है, आधार देश की प्रगति का दुनिया में इतना सम्मान है। आगे बढ़ेंगे ऊंचे उड़ेंगे, हम सबका यही अभियान है। इंडियन ऑयल, इंडियन ऑयल, इंडियन ऑयल मेरी पहचान है। सबके हितों का संरक्षण हो, हर कार्य में नव परिवर्तन हो, हर दिल में भाव लगाव का हो, विश्वास वचन और कर्म में हो। आगे बढ़ेंगे ऊंचे उड़ेंगे, ये मूल्य मेरा अभिमान है, अभियान है, मेरी शान है।